In today's video, we're going to talk about exponents, roots, and radicals. So first of all, what is an exponent? Well, an exponent is a command that tells us to multiply something times itself. For example, if I said 2 squared, you'll notice that the 2 is the superscript. So the squared is up here. So this is our base. This 2 happens to be our base, and this 2 is our exponent up here. So in everyday English, what 2 squared, so we would say it is 2 squared. What that means is it means that we are going to multiply 2 times itself. So 2 times 2, of course, is 4. If we said 5 squared, well, 5 squared would be 5 times 5, which is 25. So let's talk about perfect squares. Well, perfect squares are a topic that you're going to see over and over and over again. So some perfect squares would be, for instance, if we square 1, well, 1 times 1 equals 1. If we square 2, as we did a little bit earlier, we now know that 2 squared is 4. 3 squared is 3 times 3, which is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. And 12 squared is 144. And so on, and so on, and so on. Well, could we have other powers other than 2, for example? Well, what if we were talking about perfect cubes? Well, perfect cubes, let's do an example. If we did 3 cubed, that means 3 times 3 times 3, which equals 27. So let's list some perfect cubes. So if we have 1 cubed, well, 1 times 1 times 1 is 1. 2 cubed is 2 times 2 times 2, which is 8. And 3 cubed, as we see from above, is 27. 4 cubed, 4 times 4 is 16, times 4 is 64. And 5 cubed is 125. Okay. So, let's talk about some rules of exponents. So, rules of exponents would include items such as, what do we do when we multiply like bases? So if I multiply like bases, I add the exponent. So if we multiply x times x, we get x to the 1 plus 1, which is x to the 2nd power. So in general, our rule for multiplication of like bases says if we have x to the power a times x to the power b, since we have the same base, the base of x, we keep our base and we add our exponents, so we'll get x to the a plus b. Well, what if we divide? Well, if we divide like bases, if we had x to the a divided by x to the b, we would have x to the a minus b. So when we multiply like bases, we add the exponents. When we divide like bases, we subtract. So let's try a couple of problems. So if we took 2 to the 2nd times 2 to the 3rd, that would give us 2 to the 2 plus 3 would equal 2 to the 5th power. So if we went 2 times 2 times etc., etc., that would wind up giving us 32. So we had the same base, we had the base of 2, so we added the exponents. Well, suppose we were dividing. So if we had, for instance, 2 to the 4th power, and we were dividing by 2 to the 2nd power, we would wind up with 2 to the 4 minus 2 would be 2 to the 2nd, which is 4. Now, suppose that we didn't have like bases. Suppose we had 2 to the 3rd times 3 to the 2nd. Well, these are not the same base. We have a base of 2 and we have a base of 3. So we're going to say that 2 to the 3rd equals 8, and 3 to the 2nd equals 9. So in effect we are saying 8 times 9, which of course is 72. Okay, suppose we were working with rational expressions and we had something like 2 squared divided by 5 squared. Well, in this case we just need to simplify the top and simplify the bottom. Well, 2 squared is 4 and 5 squared is 25. So our answer is going to be 4 divided by 25. Okay. So suppose we had 2 to the 3rd times 3 to the 4th, and that was divided by 5 squared times 3 to the 3rd times 2 to the 2nd, or squared. Well, we can rewrite this as 2 to the 3 minus the 2. You notice we're taking care of this and this. And that's going to be times, we've got 3 to the 4th minus the 3 that's on the bottom, so that's 3 to the 4 minus 3, times 5 to the 0 minus 2, because we have no 5s in the top. So that's going to give us 2 to the 1st power times 3 to the 1st power times 5 to the negative 2 power. Well, the negative 2 power, of course, means we need to take it back to the bottom. So in the top we're going to have 2 times 3, and in the bottom we'll have 5 to the 2nd. So our answer is going to be 6 over 25. Now, another way of looking at this problem might have been to simplify it this way. So let's take our 2 to the 3rd power in the top, so that's 2 times 2 times 2. And we have 3 to the 4th, so we have 1, 2, 3, 4 3s. Then in the bottom, we have 5 times 5. So we have our 5 squared. And then we have 3 to the 3rd. That's going to be times 3 times 3 times 3. And we had in the bottom 2 squared, so that's going to be 2 times 2. So let's cancel out. So here we are canceling out common factors. So what are we left with? Well, we're left with 2 times 3 over 5 times 5. So once again, that's going to give us 6 over 25. So we get the same answer, but working with the exponents involved using a little bit less effort. So thank you for watching our video on the rules of exponents, roots, and radicals, part 1.